Today I'll discuss some questions related to acid, alkali, and salt, and mainly questions, structure questions from paper 4. So, example, you have dilute sulfuric acid, which is a typical acid. A student add an excess of dilute sulfuric acid to a sample of copper to carbonate. So, if we have copper to carbonate, uh, copper to carbonate is CuCO3, and we add sulfuric acid, which is H2SO4. So whenever acid react with carbonate, the product is salt, water, and carbon dioxide. If sulfuric acid is there, then sulfate salts produce. If hydrochloric acid is there, then chloride salt is produced. And if nitric acid is there, then nitrate salts are produced. So in this example, copper carbonate react with sulfuric acid. The product will be copper sulfate plus carbon dioxide plus water, H2O. And if I write the state symbol, metal carbonates, they are solid. Sulfuric acid, all acids are aqueous. Copper sulfate is a soluble salt. Most sulfates are soluble except barium, lead, calcium, and lead. Carbon dioxide is a gas and water is a liquid. Now the question is, give 3 observations that student would make. What he will observe in this when this reaction occurs? 3 observations. Yeah, bubble is one. So there will be bubbles, fizz. That's one thing. Blue solution form, because whenever a transition element compounds, so it will form a blue solution. What about the third one? Actually, bubbles are related to a gas, because the gas, as the gas is given off, this gas is responsible for the bubbles. What about the third one? Any idea? Yeah, the solid side. There is no precipitate. Precipitate, when you mix two solution and a solid is formed, then we call a precipitate. In this case, a solid is mixed with an aqueous solution. This is not called a precipitate. So what happened? The solid size will decrease. Which solid size will decrease? The solid calcium copper carbonate. So solid size will decrease or reduce. Give name of all the products. So what are the products? Copper sulfate, carbon dioxide, and water. Is it clear? Discussion. So why the solid size decrease? That's because it is reacting. The colored solution, because here in this example the solid was copper carbonate. Because it is reacting, when the substance is reacting, its size will decrease or reduce. Is it clear? Discussion one. I'll move on to another question. Question 3. When a sample of a steel is added to hydrochloric acid, it will form iron 2 chloride and iron 3 chloride. An aqueous sodium hydroxide is added to iron 2 chloride solution and iron 3 chloride. What we will observe or what we will see with iron 2? So iron 2 will observe dirty green precipitate, because sodium hydroxide with iron 2, it will form dirty green precipitate. What about iron 3? Yeah, so it will be red, brown, keep it. Because actually sodium hydroxide when added, this will iron 2 give dirty green, iron 3 give red, brown precipitate. In question 4, potassium iodide and lead 2 nitrate are soluble salt, and lead iodide is insoluble salt. Describe how a pure and a dry lead iodide could be made solid potassium solid potassium iodide and solid lead nitrate. So which salt we want to prepare? We want to prepare insoluble lead nitrate. And we have potassium iodide. We want to prepare lead iodide, insoluble lead iodide. We have potassium iodide and lead nitrate. These are the salts which are available. So this is how we can prepare an insoluble salt. So method of preparing insoluble salt, we will mix two salt solution and it will form a solid that will be precipitate. But what we have in the question, we want to prepare lead 2 iodide. So we have to prepare this lead 2 iodide. But what we have a solid potassium iodide and we have solid lead 2 nitrate. So first what we will do, the first step, we will make a salt solution. So we will add water and okay, do one thing, plan this experiment. I will let you know the answers, but I want you to plan and send answer for part A on the group. How you will plan, then I will compare your answers with the actual answer. So this will make a salt solution. Then we will mix both solution into another test tube or beaker. Which will form precipitate or PPT. Whenever two solutions are mixed together and a solid is formed, that's called precipitate or PPT of lead iodide. And then what we will do, we will filter and dry the lead iodide by filter paper. Is it clear? This is how we carry out this experiment to prepare the crystals of insoluble salt. Any doubt in this? No, it's a 4 marks. You're not supposed to write all of them directly. It should be step by step. It's a 4 marks. You cannot score 4 marks if you say take a water, add all the solid, because when you are adding all the solid into a one container, then when the precipitate will fall, that's not called a precipitate. The term precipitate means when you mix two solutions and a solid is formed, we call that as precipitate. Then you have to write an ionic equation. So how to write an ionic equation? First we have potassium iodide. It is reacting with lead nitrate, basically lead 2 nitrate, and it gives lead iodide plus potassium nitrate. The equation must be balanced. So 2 nitrates are there, I should put 2, and 2 potassium, so I should put 2. So equation is balanced. This is not the ionic equation, this is a full equation, but I should know the full equation to write an ionic equation. Potassium iodide, it's aqueous. Group 1, all salts are aqueous. Lead nitrate, all nitrates are aqueous. Lead iodide, they mentioned already, it is insoluble, so it will be solid. And potassium nitrate, all nitrates are soluble, so it's aqueous. To write an ionic equation, you will cancel out the common ion in aqueous substance. So which ions are common in aqueous substances? So you can see potassium ion. So potassium ion cancel with potassium ion, and nitrate ion cancel with nitrate ion. So what you're left with? You're left with iodide ion. So you're left with 2. I'm writing it here. You're left with 2 iodide ion. Solid, liquid, and gas we write as it is. So the substance which is solid is lead iodide. So PbI2. So potassium is cancelled and nitrate is cancelled. We are left with 2 iodide ion, and we are left with 1 lead ion. And the valency, because it's lead 2, so you should write the charge, it's +2. So 2 iodide ion plus 1 lead ion will give lead 2 iodide. Any doubt in this? Writing an ionic equation. This of total of 6 marks. So first 4 mark is for writing the experiment, how you prepare the insoluble salt, and then the 2 marks. 1 mark is for equation, correct equation, the reactant product, and the second mark is for the balance equation, writing the charge with the balance equation. There's a table which you have to memorize. I gave you that table in chapter 2, learning the salts which are soluble and insoluble. So you have to memorize that table. And remember, group 1 salts, or if they are aqueous, they are all soluble. Means if the water is there, they are all soluble. How lead is +2, it is mentioned here, lead to iodide. So you can identify how lead is +2 because it's PbI2. So iodine is group 7, so it is -1, so lead should be +2. Lead iodide is yellow in color. So, but mentioning a color is not having marks here, because here they don't want you to mention a color here. What they want is how you prepare lead iodide. Lead iodide and silver iodide are yellow in color. Look how you will write the equation. Potassium iodide is reacting with lead nitrate, lead to nitrate. As a result, it gives lead iodide plus potassium nitrate. First thing, equation must be balanced. So how you'll balance the equation? There are 2 nitrate ion. Here 1 nitrate ion, that's why I put 2. 2 potassium ion on the right hand side, so I put 2 on the left. So potassium is balanced and iodine is also balanced. Next is writing the state symbol. So the state symbol, because you make a solution, already you made a solution and they mention it's a soluble salt. Potassium iodide and lead nitrate both are soluble. So when the substance is soluble, means it should be aqueous. Lead iodide is insoluble, so it should be solid, and all nitrates are aqueous, so that's why it is potassium nitrate, so it's aqueous. Regarding the color of the precipitate, yesterday I explained how you'll the formula for different precipitate, different color substance. So lead iodide is yellow in color, that's why you can mention yellow precipitate form. That you have to learn from the table. But in this example, the color of the precipitate or mentioning the color of the precipitate is not having a mark. The important thing is how you plan this experiment to prepare an insoluble salt. So first, we write the solid, liquid and gas. So in this example, the only solid is lead iodide. So the only solid is lead iodide. That's why we write PbI2. Now cancel out the common ions in aqueous. So potassium is on the left in aqueous, potassium on the right, so cancel out. Nitrate is on the right, nitrate is on the left, also cancel out in aqueous. So what you are left with? You are left with 2 iodide ions, because this 2 is for potassium, this 2 is for iodine as well. And you are left with 1 lead ion. So 2 iodide ion and 1 lead ion produce lead iodide. So the ionic equation is, this one is the ionic equation. Okay, some oxides of some elements are listed. First we will circle, like example, the basic oxide, carbon monoxide. Is it basic or acidic or neutral? There are 4 types of oxide: acidic, basic, neutral and amphoteric. So first we will check the basic oxides. Carbon monoxide is a neutral oxide. Carbon dioxide contain a non-metal, so it is acidic. Sodium oxide is a basic oxide, so I will circle this or highlight this with blue color, the basic oxide. Magnesium oxide is a basic oxide because it contains metal. Aluminium oxide is not a basic oxide. It is amphoteric oxide. Why it is amphoteric? Because it can react. I give you a table in which you have to learn the types of oxide. Metal oxide, they can react with acid. Acidic oxide can react with base. Amphoteric oxide can react with all. And the 3 amphoteric oxides are zinc, aluminium and lead. These are the 3 in your course outline. So you have to learn or memorize that aluminium oxide is a amphoteric oxide. The non-metal oxides are acidic oxides. So carbon dioxide is acidic, silicon oxide, phosphorus oxide, sulfur dioxide, chlorine oxide, these all are acidic. Chromium oxide, metal oxide. And carbon monoxide is a neutral oxide. So metal oxide can react with acid. Basic or acidic oxide can react with base. Amphoteric oxide can react with both. And neutral oxide does not react with neither with acid or with alkali. Some of the questions, because some of the questions are from the chapter which you will study later related to acid, related to global warming or acid rain. So we'll not solve all the parts, only we'll solve specific parts. So acidic oxide or basic oxide, acidic oxide can react with base, basic oxide can react with acid. You may have acid is different thing, acidic oxide is having a different meaning. Acid means some substance which can donate proton, or acids are proton donors. Like if you have HCl, this HCl will dissociate into H plus and Cl minus. So we call this HCl as an acid. But what is acidic oxide? Acidic oxide means the oxide which can react with base. Like sulfur dioxide can react with sodium hydroxide. Sodium hydroxide is a base or alkali. So what we call this oxide, we will call this oxide as acidic oxide. So oxide can be acidic, oxide can be neutral, oxide can be amphoteric or basic. Now the question, the main question. This one is related to next chapter, so I will not discuss for. Sorry. Now the question is, which would give the solution pH 14 when added to water? What is the answer? Which of them? So answer is sodium oxide, because sodium oxide will dissolve and it will form sodium hydroxide. Which of them is colored? You can answer this question later, not now, because that's related to periodic table. But the answer is chromium, because it contains a transition element. No, it's not silicon, chromium. That's chromium oxide there. This part 4 also, it's related to next chapter. Which is amphoteric? Which of them is amphoteric? So aluminum oxide is amphoteric. Which of them is neutral? Neutral. Neutral is the only neutral oxide is carbon monoxide. It is insoluble, does not dissolve, and it does not react with acid or alkali. Amphoteric oxide and neutral oxide are different from each other. What is meant by term amphoteric oxide? What is the definition of amphoteric oxide? Yeah, it's an oxide which can react with both acid and alkali. If an oxide can react with both acid and alkali, that type of oxide is simply known as amphoteric oxide. What is meant by neutral oxide? The oxide which cannot react with, does not react with base, acid and base both. So they don't have any reaction with acid or no reaction with alkali. Is it clear? Okay, question 6. Magnesium 2 sulfate and lead 2 sulfate are examples of salts. A student prepared magnesium sulfate crystals starting from magnesium carbonate. So he's having a magnesium carbonate. So student is having magnesium carbonate and he's preparing magnesium sulfate. The student carry out the experiment in 4 steps. The student add an excess of magnesium carbonate to a small volume of sulfuric acid. So basically he mixed magnesium carbonate with sulfuric acid. So it will give salt, water and carbon dioxide. Then a student filter the mixture. Then student heated the filtrate to obtain from step 2 until it's saturated. Means until it reach a point of crystallization or crystals can form. The student allow the hot filtrate to cool at a room temperature and then remove the crystals. Question is, how did student know when the reaction had finished in step 1? How he will know that he add an excess of magnesium carbonate? Like he don't have to add no more magnesium carbonate. Yeah, good. So no phase or bubbles until the bubbles stop. Yeah, so using because what happened, magnesium carbonate react with sulfuric acid, it gives salt, water and carbon dioxide. So carbon dioxide bubbles will be there. But if a student, if there's no reaction, so how he will know that the reaction has finished? So no more bubbles. Or fizz or solid will appear or solid will not dissolve, so he can know from this method. Name the residue in step 2. What will be the residue? What will be the residue? In step 2, look, he's adding an excess of magnesium carbonate. So he add magnesium carbonate until no more magnesium carbonate react. And then he filter. So when he will filter, what will left? So it will be magnesium carbonate. Why magnesium carbonate? Because the magnesium carbonate is not reactive. So unreacted magnesium carbonate will be left on the filter paper. A saturated solution form in step 3. What is saturated solution means? What is the meaning of saturated solution? The question is, the question is, what is saturated solution? Means the definition. Yeah, good. So saturated solution, actually they are asking not what is a saturated solution is formed step 3. What is saturated solution? It means a solution which contain maximum amount of solute. The solution which contain maximum amount of solute dissolved in a solvent or a concentrated solution. Explain why magnesium sulfate crystals form during the step 4. Why there is a formation of a magnesium sulfate crystal? Yeah, due to crystallization. But why crystallization? No, there's no reaction in dissolving or crystallization. There's no chemical reaction. It is a physical change. Why magnesium sulfate crystals are formed during step 4? So ions form a compound. Basically, it's not a chemical reaction, it's a physical change. Because what happened, why the crystals are formed? The solubility, when the temperature decrease,